Hi, I'm an old guy and I do maths. Now, you've seen from the header of this video that we have a really intriguing geometrical problem, and I've kept an image of that problem in the top right hand corner of this video so that we can refer to it. Now, the problem is that the person who referred this to me had um, a basic knowledge of trigonometry. She knew the sine and cosine rule. She did not know about a thing called the ambiguous case of the sine rule. And in order to solve this problem adequately, as in to get the right answer, you need to understand that rule. So what we have is we have a square shape, which I have partially drawn in here, so that each of these corners is 90 degrees. And when you look at the entire problem, you can see that in order to solve it, you have to start here because this is the place where you've got the most information. We know that this side is 10, we know that this side is 5, we know that the total angles here are 90, that this is 70, and that therefore that is 20. And so what we can do is we can use the sine rule to figure out what this angle here is. And this is where things come to grief. So let me explain. So if I just take this triangle out of the total problem and look at it this way, we have an angle here of 20, length of 10, length of 5, angle of x. We're told that sine A over A is equal to sine B over B, so the sine of 20 over 5 is going to equal the sine of x degrees over 10. Now, if we do the working for this, which I've done over here, so I'll just pull this down so that we can keep our eye on the image. Here we have our triangle. Better put degrees in there. We've got the numbers here, so rearranging this, we get 10 sine of 20 over 5, which equals 2 sine of 20 degrees. Work that out, we get 0.6840 to 4 decimal places. That is the sine of this angle. Then we get this angle. We go to our calculator and we put that value in, and hopefully you can see that. There we are. That's what we get. 43.1516 degrees if you're rounding to 2 decimal places. Now demonstrably, that is not this angle. What is it and why? Okay, well, let's say that we accept that it is that angle. So that is an angle that is less than 90 degrees. Sorry, just let me get that into the picture. It is less than 90 degrees. Demonstrably, this is less than, this is more than 90. This we know is 20. And this length here is longer than this. Even if what we're looking at and having the problem posed to us is not to scale, we know that something is wrong because that angle there can't, as drawn, be less than 90 degrees. In fact, it's got to be a great deal less, because if you think about it, when you look at the total picture, what we've got to do is we've got to fit some other angles in here too, and this is only 90 degrees. So what is going on? Well, this is a case of the ambiguous sine rule, or the ambiguous case of the sine rule, whatever you want to call it. And I need to explain how that works, not for those of you who know about the unit circle, not for those of you who know what a sine graph looks like, This is for those of you who've not come across this before. Now, the thing is that 43.16 degrees makes no sense here. So, why do we get this? Well, if I do a quick calculation on my trusty calculator, if I take 180 degrees and I subtract 43.16 degrees from it, I get 136 degrees and some change. Now, if I ask the calculator to find the sine of 136 degrees, I get the following. Now, please note that, and note this. There are two cases where the sine, where this will give us either this or this. And that's why this thing is about 136 degrees. Now, why is that? Okay, very, very quickly. I'm going to draw a thing that's called the unit circle. And this is a circle with 360 degrees on it. This is 90 degrees. This is 180 degrees. And these are the two angles that we're looking at. This is 43 degrees, 43.16 degrees, sorry. And this is 136.84, which is 43.16 degrees away from this axis here. Now, the sine, if we assume that this is a triangle and this is a triangle, the sine is made up of two things, the opposite and the hypotenuse. Now, the hypotenuse here is positive. It's always positive because we're looking at the distance from the middle of a circle to its circumference. So that is a distance. It's always positive. This is a positive distance on the y-axis, which is here, and this is a positive distance on the y-axis, which is here. And this distance here and this distance here are the same. This distance here and this distance here are the same, and these two distances are the same. This is a positive number, this is a positive number, that's a positive number, and that's a positive number. And the sine is the opposite over the hypotenuse, and so, as a result, we get this number twice between 0 and 180 degrees, hence the ambiguous case of the sine rule. Now, how do we come to this? Well, the rule says that what we do is we take our result when it looks anomalous and we subtract it from 180 and we get this, 136.84 degrees. Another way of looking at this, and just for the sake of completeness I will do this, this is what a sine graph looks like between 0 and 360 degrees. And you will note that between 0 and 180 degrees, this thing is positive. And between 180 degrees and 360 degrees, this is negative. You don't need to worry about that, certainly not at the stage at which these pupils were at. And some of you who will not go on to do this, but who need to know about the ambiguous case of the sine rule, should simply know that sines are positive between 0 and 180, and that it's possible to get two results from the same information, one of which is a false result. And so what we can say now is that this is approximately 136 degrees, approximately 136 point, I keep forgetting the point, 84 degrees. And so, if we go back and look at our drawing, that makes sense. And what that's going to result in is you getting a correct length for here, and all of these angles in here adding up to 360, not some number in the 200s that makes no sense. And your triangle is not going to wind up looking like that. So I hope this made some sense. Thank you very much for watching. I should say that once you get these lengths and these angles, you can carry on and work out the rest of this. When I did it, it took pages and pages and pages, and it's far lengthier than one of my standard videos will accommodate. So thanks for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.